Freezing point depression and boiling point elevation of non-electrolytes. Colligative properties like freezing point depression and boiling point elevation are impacted by the number of particles in solution, not the identity of the particles. The change in the freezing point, delta Tf, is equal to N, which is the number of particles, times the freezing constant K, times the molar solution. For water, the freezing point constant is a negative 1.86 degrees Celsius per mole solution. The actual freezing point is 0 plus the change in the freezing point at standard conditions. The change in the boiling point works the same way. The difference is that Kb is a different number. The boiling point constant for water is 0.515 degrees Celsius per mole solution. The actual boiling point, since water boils at 100 degrees Celsius at standard conditions, so it will be 100 degrees Celsius plus the change in the boiling point. For example, what is the freezing point of a 1.75 molar solution of sucrose, a non-electrolyte? N is equal to 1. Sucrose is a non-electrolyte. Non-electrolytes like sucrose, table sugar, do not dissociate or form ions in solution. Thus, the number of particles in solution, N, is 1. Kf is the freezing point constant for water. It's minus 1.86 degrees Celsius per mole solution. Mole is the molality of the solution, the moles of the solute per kilograms of solution. The change in the freezing point is delta Tf. Tf is the freezing point. In this case, it's going to be water. The change in the freezing point is N, which is 1 since sucrose is a non-electrolyte, times K sub F, which is the freezing point constant for water, minus 1.86 degrees Celsius per mole solution, times 1.75 mole solution. The change in the freezing point is a negative 3.26 degrees Celsius. The actual freezing point of water at standard conditions is 0, so the freezing point would be 0 degrees Celsius plus a negative 3.26 degrees Celsius. It would register as a negative 3.26 degrees Celsius. Calculating the change for the boiling point elevation works the same way. The only difference is the boiling point constant. N is 1. Sucrose is a non-electrolyte. The boiling point constant for water is 0.515 degrees Celsius per mole solution. M, the molality of the solution, is moles of solute per kilogram solution. The change in the boiling point, delta Tb. The boiling point, in this case water, will be 100 degrees Celsius at standard conditions, plus the change in the boiling point. The change in the boiling point is N, which is 1, sucrose is a non-electrolyte, times the boiling point constant, which is 0.515 degrees Celsius per mole solution, times 1.75 mole, which was given in the problem. The change in the boiling point is 0.901 degrees Celsius. The actual boiling point at standard conditions is 100 degrees Celsius plus the change in the boiling point, which is 100 degrees Celsius plus 0.901 degrees Celsius, which is 100.901 degrees Celsius.